And I told you earlier that sometimes the population standard deviations for the two populations that we want to compare will be different. So if we can find a good reason for them to be different, then this is going to change how we conduct our test of hypotheses. So again, we conduct a formal test of hypotheses when we want to compare the differences between two population means, assuming independent samples, and that the population standard deviations are unequal, that they're different. And the steps are all the same. Here's another example from the Prison Climate Survey. Here, I took two random samples, one consisting of inmates after the riots at Belwat, and another consisting of staff after the riots at Belwat. So in this example, I was really interested in what was happening at Belwat, and I wanted to know how perceptions of environment livability were different between the inmates and the staff. So I went out and collected these random samples. I then calculated some sample statistics. And here, my question was whether the average environment livability was different between inmates and staff. So some riots happened, so I imagine that this has really shaken up the facility. So what I want to know is how perceptions of environment livability are different for these two groups. I have a null and an alternative hypothesis. The null is the doubting scientist hypothesis. Population average environment livability is the same. There's no difference between the inmates and the staff. My alternative hypothesis is that there is a difference in average environment livability between the staff and the inmates. Again, I have three alternative hypotheses to choose from. In this case, I decided to conduct a two-tailed test. Step 2, again, we set our significance level. In this context, once again, I've defaulted to the standard in science of 0.05. Step 3, I now determine the appropriate statistical test. So here I claim that I'm conducting a difference between two population means test, assuming independent samples and unequal population standard deviations. So my justification for this is that 1, I'm looking at the difference between two population means. 2, that the independent samples are independent because I do not believe that the way that the inmates and staff responded had any effect on what they put down. And 3, I make the case that the population standard deviations are different. So I have a population of inmates and I have a population of staff. Now when it comes to the prison facility, there are actually policies that forbid inmates from organizing. So they can't collectively bargain for how they're treated in their facilities. However, when it comes to staff, they are highly organized. They all decided to work for the facility. They all receive training within the same state for the same ways of being a correctional officer. And they work together. They have meetings. They talk about what's going on. They strategize. They try to act as one. So based off of this argument, I argue that the population standard deviations for these two populations are different. I then calculate the p-value. So we do that using SPSS. Here I get a p-value of 0.004. I then compare the p-value to my alpha level. And once again, the p-value is less than the significance level. So this tells us that under that doubting scientist position, that claim that the two populations were basically the same, that they were no different, then me going out into the world and actually talking to inmates and staff has given me a lot of evidence. And this evidence is showing a big difference, which is really rare if we're assuming that nothing is happening. So since the p-value is less than the significance level, we reject the null and accept the alternative. So at the alpha equals 0.05 level, we have sufficient evidence to conclude that there is a statistically significant difference in perception of livable environment between inmates and staff.